Can everybody hear me? It's good, huh? Okay. That's the bad news. You can hear me. I'd like to thank everybody for coming today. We're going to look at a CNC from Woodcraft, which is a small piranha that you see sitting over here. I happen to have another CNC at home that's much larger, has a 25 by 25 inch footprint, so what I can do at home varies drastically from what this is. I have, for those, if there's any interest, I've got some printout sheets here of what the CNC is, and there's also the cost on here. It's $1,500, $1,600 plus. If you buy it, they'll also give you a free touchpad, which helps you set the depth. So we can put those over here out on the counter, and anybody can take them. There's 6 of them.
Can I interrupt you for 1 minute? How many people are going to stay for lunch? Is everybody going to stay? Let's do it this way. How many people aren't going to stay for lunch? We're actually going to have to take a count.
Okay, the system I have at home is a system called Probotics, and Probotics, there's some literature here, has many different levels that you can go to. You can go from the $3,500 level all the way up to how much do you really want to spend. And again, there's some literature here describing the systems a little bit. It also has the website down here in the bottom where you can go to the website. You can see free demos, and they're actually very good people to deal with. They really support the machinery very, very well. I've had mine for 5 years, and I've had only one problem, and that problem was caused by me running it into something that I shouldn't have. And they sent me the parts, no charge, and it was overnight. And I just can't express how good they are to work with. The software that I'm using today is from Vertices. It's a VCarve Pro, and it's $700 to buy the software. Software is not included with the machine. And again, here's some literature with a small description of the program, and you can go to their websites. These people run some very, very good learning demos online, so you can go to YouTube, and they've got a whole host of them. Their user group is fantastic. If you have a problem, there are a group of guys in that program that get back to you almost instantly. It seems like they're on the computer all the time. I wonder if they really work for a living. But it's a relatively easy program to learn. If you can learn Microsoft Word or Excel, you can learn this. This is which is from NextWave, and we'll go through and we'll run the system. We'll show you how it works. You can ask as many questions as you want. There are a couple diagrams in here that talk about the different parts of the machine, how it operates, and then you can go to their website and you can download a little manual, and that again is pretty self-explanatory. What we're going to do today is we're going to play with this plus a few other things, some gears and other things that we'll cut on the CNC, because you have to understand the potential of what this system can do for you. This is a bracelet, and here again are some printouts of the copy of the magazine. If anybody's interested in doing this, you can do it with a table saw. And where's Alphonse? Oh, there they are. He can testify that you have to be really, really accurate with cutting your squares. And the key to this is when you're making the bracelet, to end up with, and this isn't finished yet, but to end up with, sorry, you're chasing me around. What the end up is to get all of these 8 sides to be of equal distance and have your centered off of it. Sounds pretty easy to do on a table saw, Alphonse?
Well, the pieces that you glue on don't have to be,
They're not that important.
they're not that important, it's the octagon you make,
It's cutting of the, it's,
that has to be the same.
yeah,
Pieces that are left when you turn it won't be.
yeah, the distance between them becomes irregular, and the size, so it's really very, very minute differences that make the difference on whether have a good-looking bracelet or don't. So it's described in the magazine. I'm just taking a different way to do it using some technology. So to cut, to make go over to the software here, to make an 8-sided box, or to if you make a square, and I want the square to be this to be, what was it, 2.5? And I say create it. Oh. Sorry about that. So if I want to put that in the center, I'm trying not to spend too much time on the software with you, but if I, let's see, I think I made it bigger than that then. So now what I'm going to do is I'm going to tell it I want it to center it in the center of the piece. So now it's centered. And if I wanted to make that an 8-sided, there's a couple different ways I can do it. One of it is I can just simply copy it and paste it and make it another one. Then by taking and everything's working off a center, by hitting 9, I can rotate the copy 90 degrees. And I can go through and a little bit faster than on a table saw. So now I have an 8-sided figure. There's another way to do it. So if I do this, and I tell it I want it to be and I can make, so if I wanted 11 of them, if I wanted 8. So if you go in this, there's measuring tools in this software. This is on the screen, the left side of your program is your design aspects. You can do curves, circles, or anything you want to do. As you switch over to the other side, it's defined as to how deep do you cut, what tools are you using to cut it with. It's all about generating the code to cut it. So if I needed to do a star and I wanted it to be 5 or 6, if I wanted that star to be in the middle, I go over here to this tool, tell it to place it in the middle, and it'll place it exactly in the middle. You want to delete it, just delete it. As long as it's red and highlighted, that's your active piece of, that you're working with. If you want to do an oval, you can do it manually. You can rotate them. So you can put it anywhere. You can do it manually, rotate it. You can stretch it. So you can do things that visually fit. You can measure. You can see if you touch on it, it tells you down at the bottom of the screen what size it is in the X and the Y axis. You can go in and I can tell I want to increase it by, so if I put it in there as a measurement, I go, no, I want to go 10% better than that. You can go into the program and I want to apply it to that oval that's highlighted, and now it'll make it 110% of what it was. So you can go down to the into the thousands as to how tight your tolerances are. You can do text, you can make signs. So if I wanted to do some text, and the program comes with more fonts than and we're telling it it's 2 inches high. So you can do those tests. You can do a cutout where you take the text out, or put an insert in there. So if I wanted to do a block of wood and I wanted text to be in there, but I wanted it to be, if it was black walnut and I wanted maple text, you can do a male-female fit. And I've done a fair amount of that, and there's some samples over here. It's extremely accurate. I don't know of any way by hand that you could get the accuracy that you get with this. I don't know why it's doing that. So if this is the bracelet, and basically what we have here is this and that are this center opening. That's the section we're going to cut out. This is the outside of this box. So we're going to cut this out. The hole in the middle here is, on my system at home, I have a fiber board for my base, and I screw things down into it. So I just drill a hole, screw into it, and then when the fiber board gets really bad, you just place it with a new set of fiber board. This system over here has an angular aluminum strut type system that has clamps, so you can clamp them down. The clamps work very, very well. There's some drawbacks to it, but in my system, so I have one hole here and one here. The hole here is to hold it in the center position. This is to keep it from spinning because there's a lot of torque when you're cutting with the router. So that keeps it firm, flat. I mic everything down to the thousandths that I'm going to cut with a digital micrometer, because you can cut down so that you don't go into or through the wood, and usually try to leave a paper thin layer there so you're not messing up your baseboard or cutting into the metal on that particular case so that you end up dulling your tool. So it started out like this, it ends up like this, and then you glue all these little blocks of wood on. The only thing particular about the blocks of wood is you have to make sure that they're flat so that when they come up against the surface, you're getting good. I didn't pay a whole lot of attention to that at the beginning when I first started doing this on the first couple samples, primarily because I just wanted to work through the process as it differed from what was in the magazine. And once you go into the digital realm of it, there's a lot of extra options that you have that make it a whole lot easier. So we started out with this, we ended up with this, and then glued those on there. So what we'll do is we'll take, and this is, what is it? I've measured it 100 times, I should know by now. It's 0.94 inches thick. So when I go into the properties of the system and say my piece of wood, is 0.95 of an inches thick, and that's what I mic'd it on the other piece that I had. It would tell me. I can make, on a CNC you do with an X, Y, and Z. X is across, Y is back and forth coming to and for you, and Z is up and down. So on this particular one, I normally center it down on the lower left-hand corner just by simply clicking the button here, and that says that that's where I want my origin to be. But because I'm running off of the screw hole here, I want to be close to that. I click the center. The other thing is that we're going to cut a shallower piece of wood, and this one mics out at 0.43. So that's the thickness of my wood, which is what I have already set up in the machine over there. It's just another version of this. And I tell it that that's okay. And I've said it's 5 by 5, but normally you would measure and just say that's what it is. And I'm going to put it into the center of it anyway. So now we have that. If we go, there's arcs, there's curves, there's a whole host of tools that you can do, but I don't think you guys want to sit here and learn about the software. You can spend an hour just in design on all of the different attributes that you can apply to this. So if you can think about what you want to do, there's almost always a way to do it in this. What you do have to do is you have to think from the beginning to the end when you're creating something, how am I going to do that? How am I going to grab that in the lathe? What are my options? So this is all the design side of the machine over here. If you hit that button, it takes you over to, this is the mechanical part. This says, I'm going to generate code now, and what I want to do is I want to describe how deep I want to go with each one of these. So we'll first deal with the little center ring here that we want to cut out. So by telling the system, by picking that, holding the shift key and picking that, I'm saying in between there, I want to make a pocket. So how deep do I want to go? I want to go 1/4 of an inch, so that's 0.25. What am I going to use? You can pick out your tool, so I can select. And these are all the different tools that you put in. And you can tell that right now we're using a 1/8 inch bit. So that's what I have picked as a 1/8 inch end mill. I tell it how much do I want to use of that end mill to cut. I wouldn't want to use the whole 1/8 inch bit to cut all the time, because that's a lot of stress. So what I do is I tell her to want it to use 1/4 of the width of 1/8. So when I make a cut, I'm only cutting 1/4 of that 1/8. So that's how small of a cut you make to get fine details. If you're hogging it out with a 1/4 inch bit and you want to use half, okay, but those are some big chips, and you got to remember that it won't be nice and finished around the edge. So again, I usually, go ahead. You can. It depends on what you do. Right. If I'm doing a very large area, typically what I'll do is if that circle was going to be a large area that I wanted to cut out, I'll make one extra ring in that circle, and I'll define that last cut as a very fine small cut. You can switch tools. A half a cut. What's a half a cut? Oh, it takes a full cut. On the first time around, it will take a full cut. There is no way to make. Yeah, you'll see. It'll end up eating it right out. It just chews it right away. So I've told it I wanted this end mill. An end mill has a flat surface on the bottom, and we use upcut chucks, which means that the spiral, when it's spinning in the router, it's going to bring the chips up and shoot them out. There are some down cuts, and some people use those, but I don't know why they do it. So you can also tell it the spindle speed that you want, how fast you want it to do. So this is cutting 80% of what it would normal. I can set it down to 20%. I can go to 10% if I wanted to. On my software at home for my tools, when I'm running something, I can speed it up and slow it down interactively. On this system here, you can't do that. It's got to be you set it up at the beginning and you live with what you have. And if it breaks the tool, if you go too fast on your movement of the router, it'll snap the bit. And it has done that more than I care to admit. So I'm going to tell it I want it to cut this. I want it to cut a 1/4 inch. I've selected a 1/8 inch tool, and I'm going to say calculate that. So now it's said this is what I have. And I can look at that and see it's going to take 2 cuts to do that, because I set my depth of cut as at a 1/16 of an inch. It's only going to, or an 1/8 of an inch. It's only going to go down and cut 1/8 of an inch. It's going to go around and cut it, then it'll come down and cut another 1/8, and then it's done. So now if I say I want to do this, where I want to cut. Now I want to cut the outside box, so the hexagon. So what I'm going to do is I'm going to take away all the outside, if we'll leave in the square, it ends up being just a circle around it with all of the sides cut flat. So Once again, we'll go over and tell her we want it to do. And we're going to set the depth at, well, let's set it at 3/8. We're going to use the same tool and say calculate it. So it calculated what it's going to take to do it. I don't have to tell the computer to say go over here and make the circle and draw it like this. What this program does is it generates what's called G code. And that's just a small program that when we put it in over here, it's going to run the router. So we tell it, well, let's go back and let's just show you what it looks like. You can do a simulation. So I'm going to tell it I want it to preview all. So now it's going around and it's cutting. And it's going to show you how it cuts things. So you can, and I do this every time. I do go look at what I've, and for this it's probably going to take about 5 minutes to cut, 4 minutes, something like that, maybe less, but because we're not going that deep. When I do this one on my system and I run it, it takes about 12 minutes to cut that out. The benefit is,
You could put in a bigger bit, couldn't you? Since you're
Well-
wide- since you're wide.
you can put in a bigger bit, but the minute you go a bigger bit, all of a sudden you have limitations on
Detail.
how small you can go here with the curve. Because I have to fit this into my chuck, and I don't want it to be too small that I can't grab it. Because I want to squeeze down, I don't want to expand. So I want to squeeze down, and I also have to leave enough here so that when I'm turning, I have enough left to turn off of it. So by using a larger bit, yeah, it would go a lot faster. However, it's the detail that you're looking for. So again, you can manipulate that. Look at it any way you want. You can turn the wireframes on and off to tell you how many passes it's doing. In this case, for the outside, it's going to do 3 passes, and we're not going to go all the way through because it's not my machine, and I don't want to wreck their bit or mar up the table because that's a unit they're going to sell. So at home, I have a wood base, and if I go through, it's not the end of the world. Here, you lose the bit, you scar the table, and you walk away mad. So the way we communicate with the machine over here is through a key fob. So I'm going to put this in here, and I'm going to tell it I want it to save it in a format. I want to save it in a format. There are, I don't know if you can see that or not. Right now I have, it's the Shark. But just to show you how many different file formats there are to generate code for different, like ShopSmith, ShopBot. Everybody's heard of ShopBot, where you do the lasers, you do the plasma cutters. You can run all of that with this. It'll generate the code to run all of that. It just goes on forever. So we're doing as the CNC Shark USB references the USB fob that I have, and it's a tap file format, and I set it up in inches. You can work in inches or millimeters. So we're going to say save the toolpath. It's going to say where do you want to save it, and I want to save it to my D drive, and then what do you want to save it as? I'll save it as class 1. Save it. It's already saved. So at that point, I can take this over to the system over here, And we'll turn this on. And there's some warnings. Can you? Okay, so in essence, what it's doing is it's saying if I want to go right, if I want to go left, I can run it manually. If I want to go close, so I can put it where I want. I can go up and I can go down. Over here, there's fast, medium, and slow. You can tell it to go to sleep. You can tell it to wake. So you can, in essence, I haven't put the key fob in here yet. So once I put the fob in here, but so now USB has come up, and I'm sure you can't see that, but it just tells me that there's a USB active in the system. So what I'm going to do is I'm going to put where I think I want this to create the square in here. So I'm going to put it just over here in the middle somewhere, because we've got plenty of room. It's not we're going to run out of distance. I'm going to go down. One of the things I don't like about this system is it's extremely touchy. So that right now is pretty close to touching the wood. And it's going to be a little bit off, but they make a touchpad that you can put here. You can hook it into the system, and it says when it's down there, it'll find exactly where it is, and that's what they call 0. So what I need to do now is I need to tell the this computer that on that program that I have in there that I'm going to 0 everything to 0, and it's going to say, you sure you want to do that? Because it'll remember the last place you were. So if you're going to switch tools or put another program in and cut another design, so if you're going to hog out something with a big piece, you would switch tools and say, no, I don't want to change it. In this case, I want to say yes. Now all my numbers at the top are at 0. So I can say USB, and at home I have a computer screen to work with. And this little screen here, so class 1 is what we typed as the file. So by clicking on that and saying, yes, that's what we want, and this will get noisy, so we'll probably quit talking, but and it'll get dusty, so if you have a cup of coffee there, you might want to move that. So we're going to turn the router on and say run. That's slow. The problem with the system is it should really be much slower if you're going to do something in fine detail. That's as slow as it'll go. Fast is a lot faster. The computer knows enough to say if I'm cutting the inside, I need to go this way so I get the best results with my router bit. If I'm cutting the outside, you need to go around and go back the other. So it'll do the middle of something first, and then it'll go clean it up in both directions. there's some oddities to the program that sometimes when it's cutting, it'll cut a small section first, go over and do another small section, and then it'll come back and go all the way around. There's no logic to it. However, this time it's doing different than what it did the last time I generated the same program. So it'll do it different every time. You can edit the code, but you're talking about 30,000 lines of code, and who the hell wants to do that? But it is fascinating to watch. You can and it cleans it up to very, very, very fine detail. So if there's a little micro line of fiber laying down there, it'll go back and get it. It covers everything to. I'll pass these around so people can look at them, but this is an insert. This is just an epoxy filled, and here's another insert. So those are the types of things you can do with it. I have made serving trays on mine at home because I have a much larger format, in which I used wood dowels out of black walnut, and you can do the handles, and you can do all of the holes so that they match up perfectly. It really does a very, very nice job that way. Yeah, that is what we have here is I took a bullnose router and cut that. The same as we did the pieces over here. On my system at home, I have a vacuum. I built a shield around it with a brush, and the vacuum is attached to that, so it sucks up a lot of the particles.
When you make stuff like that, you show it, you have to turn it over into the bottom, or you can't do that on the
Well, what I'll do on like that bowl, what I did is I cut a tenon in the middle of it, and then routed the outside. So I could grab it, then I could, and I usually will glue something on the back side, grab it by the chuck, turn that down, so I got another tenon. Oh yeah, that majority of that is on the lathe. Right. No, because I can't cut through with this because it's a 1/2 inch material, And the bit that we have is only 3/8 of an inch, so I'm less than that. So I told it to go down 3 levels. It's going to go, this will be the last pass. If I had my router at home, which is a Bosch, has a different collet than this has, so I couldn't bring my router bit here. I could have replaced and put my Bosch router on here, but this is what comes with the system, so I left it as is. You can step it out, so I can have 10 of something laying on the board. You can tell it to go start cutting, and you can walk away and do something else. And there's a stop button here that allows me to stop it. It won't allow me to run again, but it will allow me to do an emergency stop. So if something's wrong, you can stop it. But when it's finished, it's going to go back to the center and say, I'm done. If you break a bit, you go back to the beginning and start over. And that's one of the main reasons. The concern is that it's too fast. So if I'm using a 1/8 inch bit, and it's 2 inches long, because this can go down deep into something. If I'm running 2 inches and I break a bit, and you do break bits, especially at this speed, that's pretty fast. You can see the bit actually bend. And if it's running into a hardwood, it'll snap. You're kind of screwed. You go back to the beginning and say, let's start over. It'll do it exactly where it is. Now, if I simply said run again, it's going to go back and it's going to run exactly where it is, because it knows where it is in the X, Y, and Z axis. So when I was doing if you look up at the light, you can see we're pretty close to going through. So you can take a knife and cut around and what's critical on this is the fact that these edges are all the same. I don't know if anybody wants to check it, but here's a micrometer. You can check as close as you want in terms of a cross distance. Are they all the same? You know, it's much closer than you can get with a table saw. So what you have is then what you do is you take the piece that you've just generated and you cut it down and you glue a different colored wood on the outside of each one of them. So on this, you'll notice my hole is off center from this hole, or this rounded part that I cut. The only thing that's really important here is the fact that you're grabbing here, and that's the new center, and that's what everything rotates off of. So now we'll take and we'll put this on the lathe. Unless you want to watch it cut this one. Let me show you how difficult it is to create something like this. So let's just create this one real quick. So now,
What does CNC stand for?
CNC, computer numerically controlled.
Thank you.
So before we were looking for an octagon that fit within that circle, and what we're going to do now is we're going to delete that, and I want to create, pass that around, and then pass this with it. What we're going to do is create a series of little boxes or squares or diamonds or whatever. Because we know that we're running with a 1/8 inch bit, we're limited to the arc that we can do in terms of on the inside and outside. So we can't do square corners. It has to have a minimum of a 1/8 inch round to the inside corner. So to do that, if I wanted to do a what are those? I don't remember what I made them. Oh, it's a 1/2 inch. So if I highlight the box and I tell it I want to make a 1/2 inch by 1/2 inch or a 1/2 inch by a quarter, whatever I want to make it. If I highlight the box and select box, I can do an inside, internal, or external. So if you can see that up there, right here, where it's switching. So I wanted to do that, and I want to apply to that box. I want to take and center that box. And by clicking and getting that little crosshairs, that allows me to use the keyboard to maneuver it. So now it's in the center. And I'm going to bring it over to the outside here, and because I'm cheap, I don't want it to be a really big hole because I don't want to put a lot of epoxy in there. As my wife would say, I'm cheap. So frugal. Frugal is my word, cheap is hers. You can zoom in and measure the distance. As to what it is, it's 1.4, or 0.414 inches in. So if you wanted that to be a 1/4 inch, you could type in a 1/4 inch, it'll go to a 1/4 inch distance. There's a lot of keys on the keyboard that gives you flexibility to say, I want to, if you're zooming in like this and you're looking at something in great detail, and you're really down very, very fast, you can just hit the F key and it brings back to the full screen. So there's a lot of little shortcuts that you may or may not experience. So what I want to do is I want to make a circle of those around the outside. So by highlighting that and going down to here, this little function, and it says, how many do you want to make? I want to make 6. And I want to copy it off of center, and I'm going to do it at 360 at the distance I'm already at. So by hitting the button, it says, okay, well, I guess I want more than 6. That's 10. I think I want a couple more. I want a little. Let's do 12. So that's how difficult it is to create that pattern in there. So we can go over and we can say, let's cut that out again. You guys want to watch this cut out, or do you want to? Then we'll go on the lathe after this. So let's cut this out. I want those to be little pockets. I want them to go down 0.375. I want the same end mill. And I'm going to say calculate. So in essence, it calculated how to cut all of those. I cut this and that. I'm going to make another pocket. I have to go down 1/4 of an inch because that's all we really need to grab it, and it's calculated. Preview the tool path. I should have reset it. So that's what it's going to do, and it's going to cut it out, and that's what we'll end up with. I'm going to highlight. I'm going to say, oh, I got to get my. So I'm saving it again as the same format on the D drive, and I'm going to save it as class 2. So now it's saved, and the only thing I really have to do is go over and throw another piece of wood in. I really like the clamps on this one. It works very nice. I mean, it really holds it secure. You know, and all in all, they make a larger version of this. I have not run that one yet, but this one, you know, you'd be amazed at how much you can do in a small area. This has a 12 by 12 cutting area, and class 2. Turn the router on. You guys are welcome to come up and take a look at it when it's running. It's not going to do anything other than run. So if anybody wants to come up and take a close look while it's running, feel free. I usually take a sandpaper and go along the top edge just to take some of the fiber away. Oh, no.
When you're done, can you tell, or maybe some guys that are experienced also, how you do your resin?
The
Those are a dish you have that has around.
the resins, I went to Hobby Lobby. I don't know. It's in a little blue box. Yeah, down in the. But that's what I used. Yeah. Yeah, I don't remember what it is. I mean, there's a lot of different resins you can use, but
Is it a solid carbide cutter?
yeah,
The carbide is solid, the cutter is solid carbide.
no,
You don't have it,
no.
'cause that's all I ever used.
Oh, well, those are,
But I was cutting metal, so
yeah,
with the carbide, you don't get the flex.
yeah,
But
Yeah.
it's a lot.
yeah. But if you do, carbide is also more brittle. I mean, it'll last a lot longer, but
You jack the RPMs up on it a little bit, then
yeah, yeah.
leafed holes that you have with the acrylic. Are those holes drilled when the board is solid and all filled with acrylic?
Right. Oh,
They're stepping in the lathe and you're doing things at the same time.
you can do an awful lot. You know, you just set it up and run and go over the lathe and work something else. So I do that a lot.
If you just, when one was finished, if you have the program in there, then you just slide the next board in, clamp it down, and it'll grab the next board.
You just say run.
Do the same way. You don't have to measure it out.
So all you do is say run. So if you're going to run the same thing again and again and again. Without the lighter width. Okay. It's okay with me. Okay. Once you've waited a day or 2 or 3 for the glue to dry to make sure that it's not going to come off at you, then you can throw it on the lathe. And of course, because the center of what we're now basing everything off of is the ring that we cut, and we're clamping down to the center. First thing I want to do is true up my face just a little bit. Do I sound like Darth Vader now? Luke, I am your father. So I'm just going to go ahead and true up the face a little bit. So we're okay there. What I'm now going to do is try to mimic what I have on the inside already, where I grab it, so I can grab it from both sides. It doesn't really show that on the book, but. So now I know that I can grab it. Because I don't want to hit the metal on the chuck because I'm close to it. So I usually go this side and then I'll flip it around and do the other side, so that and I'm going to turn the light on because I. So if you start looking at what do all these little diamonds look like here, are they all the same? You'll see that it should be pretty close to what you're anticipating. I found that using the skew gives me the ability to rotate around nice and get a nice clean surface, and you don't get up and down. You really don't have room to ride the bevel to get that type of a cut. So the other thing that you'll find is you have to stop often, because it is a very, very short distance between where you're cutting and where the wood goes away. These are really, when you get down to it, they're not very thick. So I'll stop and start a lot. Because we know that we're working off the same center point on both sides, we can rotate around and what I'm really looking at is not necessarily the tool, but I'm looking at the top edge up here, looking down at that to see what my curvature is versus looking at the tool, because you really can't tell anything other than that. And so you can see we're starting to get close to where, and there's one where some of the woods chip a lot easier than others. I put some of these here have palm wood on them, and palm wood chips out real easy. And so you can see little chips in there. It's just a product of the wood that,
If it's a grain the other way, it might chip less quickly.
yeah.
Pretty good.
As I found out on a couple other ones, the wood goes away really quick when you get down here, as all of a sudden there's nothing left, and it doesn't take much. I'm taking some very, very light cuts, and it just goes away in an instant. So that is not too bad, but I think we want to go down and make the dots just a little bit smaller. And we do have one that's chipped out, but let's go a little more. It's all about patience. So I kind of like that. I think that other than the chips that are in there, I think it's pretty uniform. The next step that we do is we're going to take, because what I want to do now is take the center out so that I can take and put some other jaws on here. because I've got two centers that I can work with, and now I can grab it from the outside. I can switch back and forth as I feel I want to. And I've got this side here fairly decent. I might sand that just a little bit, but just to get it around. And then I'm going to come over here and touch up this. But before, where I was squeezing on the center, now I'm going to take and expand here so that I have this free. And one thing you have to remember is you still got those jaws on the inside, so you can't just go hogging in there. Now the metal jaws are really not that far from where I'm cutting here. So what I do at this point is I take these jaws off and put another set of jaws on that allow me to capture this by pressure on the outside. So by going back and forth between these jaws, I can finish it then. Pardon? Yeah. So that allows me to capture it that way. Whenever I got foam on the outside, it allows me to clean the inside up, and I can finish the inside. Then I can put my other jaws on that have long tongs coming out, and I can finish the outside. And that, in essence, would be how I would finish it off. Oh, yeah. I did not pay a whole lot of attention to putting the woods down on there. I probably should have been more diligent about that. In terms of when let's see, do I have one here? On my octagon, where I didn't have the wood come all the way out, I just put small chips on there. If I had been more diligent about making sure that that was from corner to corner, I would have gotten better results. I also, on this one, this has got palm wood on it, so I put the grain running this way so that it doesn't chip as much. I have another one that has it going cross grain, which is the worst way you can do with a palm wood. But for me, it was just cutting a whole bunch of chips, gluing them on, which is the most tedious part of the whole thing. But you can get down where you have a nice little center, you put it in here, and you turn it. You can't, with these jaws, you can't go as fast. You can only go 400 or 500 revolutions. Where I like to do everything at higher speeds, so then you have to cut it very slow. But as long as you have a sharp tool,
You could go back on there with you could have a fitting like this on the outside, and drop it in there, and then cut it out with that, with the CNC too.
no, because you can't find the exact center.
Oh, okay.
To find the exact center, that would be difficult at this point, and I would not want to do that. Yeah, I would not go back to the CNC, because when you're talking there, you're talking about very minute adjustments. So by simply laying that in there, spinning that, you can clean out the inside of it real nice. If Kelly, how much time do we have?
11.
Okay, so I'm gonna try doing this one, which is an epoxy, which is we just cut that pattern out. So I'm gonna try this. Last night it was still soft on the inside, and I did that the day before. So we'll try cutting this one, because I think it should look pretty cool. They have the new jaws out now that you could interchange and snap really quick from, I think it's Nova, where you can snap the jaws in and they're very fast. These you have to take the set screws out, and it becomes somewhat of a, do you want to spend the time doing that? Can't tell you how many times I've had the face mask on where I've gone down and it's like, good guys, nobody's here to watch me do that. But I do wear the face mask all the time when I'm turning. There's very, very few times that I don't wear it. I like to spin it at higher speeds. I don't like going slow. It gets a much nicer cut. I do have a CBN set of wheels at home. If you don't have those, they're excellent for sharpening. They're just mind-boggling how good it does. And I refuse to sharpen mine on a regular stone anymore. Anybody have any questions? All we're really doing is running down till we start seeing black.
Just finding the epoxy there.
Yep, so now I know where the epoxy is. I have to clean up the face on this side a little bit so I know what my depth of the epoxy is. So now I know where the epoxy is. I can get a little bit of indentation if I press, but I think we'll be okay. Certainly won't sand it at this point. And what I want to do now is cut that groove so I can grab it from both sides. And one of the benefits, Mark, you know all about that, right? Working with epoxy. So now it's a matter of creating the curve and getting the look that you like. Doesn't seem to score very easy, so. Well, let's go down the outside and see what it looks like. So we're generating a little bit of heat, so it's definitely a little softer now. So I would let this cure for a day or two before I go any further. But in essence, you can see what the possibilities are. So I'm going to leave both sides on it yet because I really want to let it set up and get some time to take it down so we get a nice smooth cure. Any questions or?
Yeah, how much time do you have in each one of those?
Well, you saw how long it took to cut this here. And then I mixed epoxy and poured it into those holes. The only thing I did is I took some duct tape and glued it, or pasted it around the outside so it didn't run in and fill on the inside. So not very long. You see how long it took to cut. I mean,
And if you went to an art fair, I mean, if you set up a booth or something, I mean, what could you theoretically ask for?
oh, I would think you'd be able to get $25, don't you think?
I mean, I don't know, I'm just asking.
I don't sell much of my work.
I know I don't either.
You can. Yeah, Tim, you've done some sales on the outside. I don't know what you could sell little bracelets for, but probably, yeah, 20-25. You can, with the CNC, you can set it up so you're doing 8 or 10 of these up at a time. So you can let the CNC run on a piece of wood, and all you're doing is over here work. It's relatively easy to do. It's easier than the magazine, that's for damn sure. And when you do something like this where you have a design that you're really not, it just becomes a how do you feel about it? The kids love them. And you can do all, I don't know, there's rosewood there's all sorts of woods that you can put together. That's it. Thanks you guys for coming and paying attention. You're going to need the vac.